Hey, fifth graders, I hope that you were successful in making your rubber band stretchers and you are ready for lesson 1.2. Before we start, I do want to mention that in that rubber band stretcher activity, you should have noticed that the figure was similar. It should have been about twice as large. So the side lengths would have doubled, the perimeter would have doubled. The area, though, should have been about 4 times as big because if you're doubling both dimensions, then it would quadruple the area. And we will continue to talk more about that as these lessons go on. The other thing that you may have noticed was that the angle should have stayed the same. And again, that's something that we will continue to talk about as we go through this unit. So in 1.2, we are going to continue talking about scaling up and scaling down, corresponding sides and angles. In problem 1.2, let's see, it says, in the last problem, you worked with images or scale drawings that were similar to the original. Those scale drawings were larger than the original figure. In this problem, you will work with scale drawings that are smaller than the original. You will also learn more about what it means for figures to be similar. When you study similar figures, you often compare their sides and angles. To compare the parts correctly, mathematicians use the terms corresponding sides and corresponding angles. In every pair of similar figures, each side of one figure has a corresponding side to the other figure. Also, each angle has a corresponding angle. So corresponding would mean the ones that go together. Okay. So in this picture, you can see that the corresponding angles are B and E because they're in the same place on the triangle, right? A and D would be corresponding C and F. Same with the sides. A and C, the bottom, would correspond with D and F, right? A and B, the long, tall side, would go with D and E. And the diagonal B and C would go with E and F. So corresponding one means that it's the one that matches up on the other figure. So remember, there are 2 ways to identify angles. You can identify an angle with 3 letters. The angles in the small triangle on the previous page have the following names. So BAC or angle BAC. So they have the word, or you use that little angle symbol. Remembering that when you're doing an angle, the vertex is always the middle letter. So in angle BAC, A is the vertex. Let me see if I can get back to the previous page, right? So BAC would be talking about this corner angle here, and it would correspond with EDF. You can also name an angle by its vertex. It's important to use this method only when it's clear which angle you are referring to. So here we could say BAC is also angle A, BCA is also angle C, angle ABC would also be angle B. It says, what names would you give the angles of the large triangle? So you could look back and practice and say which ones would those angles be called. So Daphne thinks the rubber band method is clever, but she believes the school copier can make more accurate copies in greater variety of sizes. I'm pretty sure it's going to be definitely more accurate. She makes a copy of the Super Sleuth with the size factor set to 75%. Then she makes a copy with a setting of 150%. The results are shown below. So you can see the original, the 75% and the 150, and there's not a ton of difference between these two. These, you can tell this one's quite a bit bigger. I'm going to click here and see if it will give me that little link. It doesn't look like I did it. How are these copies of the original logo like the copy you made with the rubber band stretcher? How are these copies different? So they might be different sizes. They might be neater. They might be the same in that they have the same shapes, they have the same angles. How are they like the original and how are they different? Again, they look the same, but they have different lengths. They are smaller or larger, but you can kind of see here those 90-degree angles in the corner are those staying 90-degree angles. The angles are not changing as the size of the shape changes. We'll talk more about that later, like I said. So we're going to use the figures on the previous page. For each copy, do the following. So describe how the side lengths compare. So you will have to measure with a ruler. If you don't have a ruler at home, you could use, draw something and then use it to measure both sides and say it has this many. If you have your graphing paper notebook, you could use the little squares, compare how many squares one is to the other. Same for the angle measures, try your best. I did tell you they should all be the same, so that gives you a big hint, but if you had a protractor, you could measure and prove that. How is the perimeter in each copy of the triangle similar to the original? Describe how the area of the triangle compares. You'll have to measure and compute the area. Remember, the area of a triangle is 1/2 base times height. In B, you would notice how the relationships in the size comparisons you made in question A relate to the copier size factor. So as you're looking at each triangle, how is that 75% shown? How do you notice it in your size comparisons? What's happening to the side lengths? What's happening to the perimeter and the area? In question C, it says, if two figures are similar, what is the same about the figures and what is different? I've given that answer a few times in this video. C2, if you wanted to achieve a 150 increase with the rubber band method, what would you do? So I told you at the beginning of the video that the rubber band method should have given us double the size. So what copier factor would that be? If you're doubling something, what percentage increase are you doing? And how would you maybe make that into 150? So I'll give you a little hint. If you're doubling something, the copier size factor would be 200%. So how could you change that rubber band method in order to make it a 150 increase? And then today you have ACE problems 5 through 7 and 19. So I had to put them a little bit funky on the page here. So this is 5, 6, 7, and then 19. All right, I hope that your lesson today goes well. Don't forget that we have a 9:30 Google Meet, which you can come and ask questions or I can explain things more. And then also tomorrow is Thursday and you will complete the investigation 1 review. All right, have a great day. Hope all is well.